Hello, in this video we're going to look at a constrained optimization problem where we have inequality and non-negativity constraints. Here's the function we want to maximize. We want to maximize z. And it is subject to the following constraints. 75 minus x minus y has to be greater than or equal to 0. And now our non-negativity constraints, x has to be greater than or equal to 0, and y has to be greater than or equal to 0. We'll start with a Lagrangian, and we're going to take some partial derivatives. So you'll notice this first constraint up here, we've got lambda multiplied by the constraint. So we're going to take the partial derivative of the Lagrangian with respect to x, and we get this result, setting that equal to 0. We take the partial derivative of the Lagrangian with respect to y, and we set that result equal to 0. And finally, we take the partial derivative of the Lagrangian with respect to lambda, and we get back our first constraint. The next step is I'm going to take our first partial derivative over here, and I'm going to solve that for lambda. So lambda equals 10 minus 2x. Then I'm going to take our second partial derivative result right here and also set that equal to lambda. We have two lambda equations, so I'll set lambda equal to lambda. We have the following. I'm going to simplify this and divide through by 2. So y equals 85 plus x. We're going to plug this result into our third partial derivative. So 75 minus x minus y, where y is 85 plus x. And we're going to solve for x. Moving on to the next slide. Solving for x, x equals minus 5. So this violates our non-negativity constraint. So to satisfy the non-negativity constraint, we're going to just set x equal to 0. And we're going to plug this into our constraint and solve for y. So here's our constraint. Plug x equals 0 into it, and now solve for y. Y equals 75, and as we said, x equals 0. And that is the solution to this problem. Okay, I hope you found this video helpful.